हेलो स्टूडेंट्स, गुड मॉर्निंग टू ऑल ऑफ यू। स्टूडेंट्स, आज का हमारा टॉपिक है मोमेंटम और लीनियर मोमेंटम। बेसिकली व्हेन अ बॉडी इज इन मोशन, सो इट्स मोशन इज डिपेंड्स ऑन its two factors. One is mass and second is velocity. And in the previous class we learned that the according to first law of motion, a body cannot able to change its state of rest or motion by itself. So, due to application of force, a body get a velocity and the product of its mass and velocity is linear momentum. That is, the linear momentum is the quantity of uh, the quantity of motion that remain constant due to application of force. Okay, so we can now write it. uh, Amount of motion in a body depends on its mass and velocity. Okay, and according to first law, according to first law of motion, a body unable to change its state of rest or motion by itself. Okay, therefore we can define momentum in the product of momentum of a body is defined in the product of its mass and velocity. Okay, now let a body of mass m and moving with a constant velocity, then it is very clear the momentum it have is also constant. That is, consider consider a body having mass m and a constant velocity, constant velocity v, then it have a constant momentum. Okay, that is momentum momentum is equal to mass into velocity. Okay, and it is denoted by p, so p is equal to m into v. And student, it is a vector quantity and it has direction as in the direction of velocity. Momentum, or we say linear momentum. Linear momentum is a vector quantity it have direction as in direction of velocity. Okay, its SI unit is kilogram meter per second inverse, and CGS unit gram per centimeter second inverse. Okay, vector form of momentum is vector p is equal to m vector v. Okay, its dimensional formula, its dimension is mass for m and velocity for lt minus 1. This is the all about momentum. Just copy it. Of a quantity. Momentum is a quantity, that remain constant under the force. Okay, Okay. Next is uh, force and change in momentum. Okay. Students, as we learned earlier, if a body is placed over the surface on any surface, then if it is at rest or it is at any position, then it will not able to change its state or position by its own. If we want to change its position, then we need to apply a force on it, which will try to change its position. For example, this duster is placed over a surface on the book. Then if we want to change its position, so we need to apply a force on it like this. Okay. So what we observed here, when we applied force, see here again, when we apply force, the body will get motion or a velocity, and when we remove the force, we observe that its velocity becomes zero and body it is at rest. That is, first thing is the position of the body will change from one point to the another point. Second, due to application of force, it will get a velocity. Initially when we applied the force, it will get the initial velocity that we called u. The body have mass m, and when we remove the force, what we observe, the body is at rest. That means its final velocity after removal the force will become 0. So due to application of force for a time, the body get two kinds of velocity. One, initially when the force is applied, it will get a velocity u, for which it travels so far. Clear? Now when we remove that force, we observe after a distance the body remain at rest. That is, the quantity force produce momentum in a body. For that time it will work on it. Clear? So we say, or Newton observed this thing, that the force applied on a body is directly proportional to the change in momentum in the body. Now we understood about or derived the formula for motion according to Newton's second law. Okay. According to Newton's second law, according to Newton's second law of motion, this is also second law of motion. Okay. The rate of change of momentum, rate of change of momentum is directly proportional to proportional to the force acting on it, acting on it. Okay, and in the same direction. Okay, this is second law of Newton. Now consider a body of mass m, mass of body is m, force applied capital F. Due to application of force, it will get initial velocity u, and after removal force, the body at rest, or it will get the final velocity v till time t. Okay, according to second law of motion, or we say Newton's second law of motion, that is the rate of change of linear momentum is directly proportional to the force acting on it, and in the same direction, that is F is directly proportional to rate of change of momentum. Okay, now we will get the rate of change of momentum. We say dp is equal to the initial momentum is this, the final momentum minus initial momentum, or we say here as del, then dt is equal to t. Okay, therefore after applying these values, mv minus mu upon t, here m is common, so f is proportional to m v minus u upon t. Therefore f is proportional to ma, where a is equal to v minus u upon t. Okay, now after removal this proportional to sign, we get f is equal to k ma. For removing this k, for here the value of k is 1. For find the value of k is 1, we need to define the force, that is if force is equal to 1 Newton, mass of body 1 kg, and it will get acceleration 1 meter per second square. Then we can see that the 1 Newton force, 1 Newton force is that force, which produce 1 meter, which produces 1 meter per second square acceleration in a body of 1 kilogram. Okay, this is the definition of 1 Newton. Therefore we get force is equal to ma. Okay, this is the quantity which Newton explained its first law, that is, after applying a force, or a force is the quantity which try to change the motion or state of motion or rest of a body. ठीक है, this force is a vector quantity, and in vector form it is written as m and vector a. Okay, this is its SI unit. SI unit of force is Newton, or we say kilogram meter per second square. Okay, and CGS unit is dyne, or gram centimeter second inverse 2. Okay, then by comparing the 1 Newton to dyne, we get 10 to the power 5 dyne. And dimensional formula for force have dimension m l t minus 2. Okay, just copy it. Then we are understood about the second expression for this force in the term of force is equal to change in momentum, which express that the force is measure of change in momentum. Just copy it. Okay, now from second law of motion, we get force is equal to m into a, and we know that a can be written as v minus u upon t, as a is equal to v minus u upon t. Okay, now this m multiply inside, f is equal to mv minus mu upon t, and student, we know that mv minus mu is change in momentum, that is p, in the interval of time, in time interval del t, that is equal to t. Therefore we can say f is equal to dp upon dt, or simply del p upon del t. Therefore in vector form we can say that f is del vector p upon del t. This expression gives the quantity of force which is equal to the change of momentum in time. By this operation, this formula, by this expression, rate of change of momentum, rate of change of momentum rate of change of momentum is equal to force applied on the body. Okay, this is the most important result or significant of the second law of motion. Just copy it, then we are taking one example related to the same topic. Okay. Okay, students, we have a problem related to the second law, that a car of mass 600 kg is moving with 20 meter per second with a velocity 20 meter per second is brought to rest over a distance 50 meter. Okay, we need to find retarding force and time it take to stop. Clear? First, find in the problem which is given to you and what is the condition. Okay, so mass is given to you and the velocity with which it moving, and after that brought to rest, which means ये वाली जो आपकी वेलोसिटी है वो u है, और जो ये रुकेगी ये आपको सेकेंड वेलोसिटी देगी, और आपको एक डिस्टेंस गिवन है. क्लियर? सो नाउ वी स्टार्ट द सॉल्यूशन. वी हैव mass m is equal to 600 kg. Initial velocity u 20 meter per second. Final velocity v 0 meter per second. And also we have distance s is equal to 50 meter. Okay, we need to find, one is retarding force and second is time. Okay, for find retarding force हमारे पास फॉर्मूला है F इज इक्वल टू ma अकॉर्डिंग टू सेकेंड लॉ. So this can be calculated by m a. ठीक है, इसको हम ऐसे भी कर सकते हैं, that is v minus u upon t. Clear? The value of a. Therefore, according to Newton's second law of motion, okay, that is force is equal to ma, and this will you get v minus u upon t. Therefore F is equal to m. The weight of the car is 600 and velocity is 0. 1 minute. 1 minute. According to second law, F is equal to ma. Now we are going to calculate the value of acceleration. Okay, students, we have initial velocity, final velocity and the distance. So by using the third equation of motion, we can calculate from here v square minus u square equal to 2as. Now v square we have 0, u we have square of 20 and 2 into a which we need to calculate and into s is 50. So minus 400 is equal to 100 a. So from here we get minus 4 meter per second square. This is the acceleration which the driver applied. Therefore force is equal to 600 into acceleration minus 4. So we get minus 2400 Newton. This is retarding force. Force which is required to stop the car over a distance 50. Okay, now for time we have a is equal to v minus u upon t. So we get from here t is equal to v minus u upon a. Therefore v is 0, u is 20 and we have a is minus 4. Therefore we get 20 upon 4 is 5 seconds. This is the final answer as asked in the question, that after 5 seconds the car will stop after covering a distance 50 meter. Okay, just copy this solution and thank you.